Okay, I'm going to go ahead and go through each of these problems on this retake practice test here for those who need to retake Thursday or Friday. Number one, ratios of angles A and B are 8 to 2. We normally see that ratio symbol right here that we're going to put an x behind each one. So we have 8x plus 2x is 10x. We see that angles A and B form a line, which means they form a linear pair, which means they're supplementary, which means they add to 180. That's why we said equal to 180. So 10x equals 180 divided by 10 on both sides, x equals 18. Go back and read the question. What's a smaller angle? Obviously 2x is smaller than 8x. So you're going 2 times 18 and we get 36. Over to number 6. Let's work our way down horizontally down the screen. Plot the points, and it says determine the most precise name of the quadrilateral. Well, this side and this side are parallel, so we have at least one pair of parallel sides is the definition of trapezoid. And then if we were to look at these lengths right here, both these two lengths are congruent. So we have two sides that are congruent. When we have at least two pairs of sides that are congruent, it's isosceles. It's like an isosceles triangle. So we have an isosceles trapezoid right there. Number 2, this is our standard one with finding the R at a certain ratio along a segment in between A and B. For segments A and B, that means the A and B are the endpoints. R is somewhere in between. And now if we look right here, it says the length from A to R is 2. Remember, it's a 2 to 4 ratio, so we can put a 2x. So if I want to put a 2x right there, I can put a 2x. A to R is 2x. And then from R to B is 4x, as it says, because it's 4. Okay, so the total parts for the whole length would be 6x. So from A to R is 2 out of the 6x, or 2/6, okay, which I just reduced down to 1/3. Notice I'm saying I'm going from A, so that's why my ratio is 2/6 or 1/3. If I was to start from B, it'd be 4 out of the 6, or 4/6 or 2/3. That'd be right here. So starting from A, I first write down x and colon and y colon. I put down the x coordinate and the y coordinate of point A. So 1 goes here, 6 goes here. I draw myself my little triangle since I'm going from A over here and then down to get to the R. So I went plus in the x direction. That's why we see a plus right there. And then I went minus in the y direction. So that's why I see 6 minus. That ratio again is 2/6 total, 1/3. And then I look at the total x distance from 1 to 6 is 5. And the total y distance, 6 to 2, is 4. So this, what you put in parentheses here, is the total x distance, because it's the x coordinate, and this is the total y distance, that's the y coordinate. Now we just plug that in a calculator and round to the nearest tenth. Go back to see what it tells you to round to. So you get 2.7 and 4.7. So here's the answer right here in point format. All right, next one. Number 3 will do. Again, I plotted the points -7, 7. So let's just estimate that. Say -7, 7 is right there, and then 2, 4 might be like that right there. Again, connect them. Okay, this is A, and this is B. Okay, and we know R lies in between there. Okay, somewhere in here. Now notice, we have to pay attention to this, says the length of AB is 3 parts. AB happens to be the entire distance, so this whole distance is 3x. So 3x equals the total x distance, and 3y equals the total y distance, because A to B is the total distance. It's not like up here. Now look at the total distance from -7 to 2 is 9. That's why we have 3x equals 9, so x equals 1. So every time we move 3 in the x direction, that's 1 part. Okay? And 3y equals 3. 7 minus 4 is 3, so 3y equals 3. Y equals 1. Every time I go up 1 from the B, or if I went down 1 from the A, that'd be 1 part. I'm going down, 1x going down. Okay, now I look for where it shows me a relationship in terms of either A or B compared to R. Well, right here, it only gives me a relationship from B to R. So that means I'm going to start at B. And I know from B to wherever the R is, we'll just put it right here, for example. Okay, it is only one part away from B to R. It's only one part away. Well, we can just calculate what one part is. One part in the x direction is 3, and one part in the y direction is 1. So again, I put my x and y down. I write down then the x and y coordinates of A and B, 2 and 4. If I was to draw my triangle, it doesn't matter if I draw the triangle down like this or up like this, so we'll go up this way this time and then back. Because again, up is the y direction. Doesn't matter if I go up from down here or up here, I'm still going up, so it's positive in the y direction. And notice that's why I see a plus right there, and it's negative in the x direction. That's why I see a negative right there. That's where I get those two signs from. And then again, now I just put in one part. One part in the x is 3, so that's why I'm subtracting off 3. One part in the y direction is 1, so I'm adding 1. 2 minus 3 is negative 1. 4 plus 1 is negative 5. And again, I could check that if I actually plotted those on an XY coordinate plane correctly, like in a graph, if you want to use on your practice test and plot these actual points and connect them, negative 1, 5 would be on that segment. And that's an easy way to check to see that I've done that correctly. All right, over here to number 7 now. Number 7 says what's the exact perimeter? That means leave radicals. Just reduce your radicals if they're reduced, but leave the radicals if there's radicals in the answer. So the first thing I'm going to do after plotting the points is to go ahead and draw my rectangle around the outside right there. Okay, and then I'm using Pythagorean theorem to find each of these side distances. A squared plus b squared equals c squared. So here I have a squared plus b squared equals the length of this side c squared. So 81 plus 36 is 117. Square root of 117 breaks down to 9 times 13. So it's square root of 9 is 3 times square root of 13 doesn't break down. So 3 root of 13 right there. Over here, we have 8 here and 1 here. So 64, 8 squared plus 1 squared. 64 plus 1 is squared is 65. And lastly, I'm going up 1 and right 7. So again, 7 squared plus 1 squared. 49 plus 1 is 50, which then simplifies to 5 root 2. 25 times square root of 25 times square root of 2 is 5 root 2. Okay, so there's my exact answer. Then I take that answer and 8, and just plug in the calculator, and I get 25.9 around the nearest tenth. Okay, now we're going to use these same triangles. We're going to find the area of each of these triangles here. Okay, to subtract off from the area of this rectangle, and that will give me the area of the triangle that they want the area for. So again, you must show your work. So I do the area of the rectangle first. 9 times 7, 63. I subtract off each of these areas. Remember, the area of a triangle is 1/2 base times the height. So I have, it doesn't matter which one I take the half of. So obviously I want to take a half of an even number. So I'm not dealing with a decimal. So half of 6 is 3 times 9 is 27. So that area is 27 right there. Of course, I could have just done 9 times 6, 54 divided by 2 and I get that. Same thing. Here I'm doing 8 times 1 and taking half of that. 8 times 1 is 8. Half of that is 4 for that one. And then I have 7 times 1 is 7. Divided by 2 is 3.5 for that area. So you should put these areas into each one, and then you go ahead and write them and subtract them off from right here, like you see right here. So I have the 63, the rectangle, minus off that triangle is the 27, minus off this one's the 4, minus the 3.5 for that one. Put in a calculator and you get 28.5 square units. Don't forget anytime it's area, it's square units. You must have a degree 2 on there. If it's just a straight distance, then it's just u. Okay, over here now to number 4. We have negative 6, 6. So if we want to plot that, okay, so negative 6, 6, let's say is right there. And then it says negative 6, 3. That's just 3 up from it right there, say for example. Again, we're just needing an estimate here because the numbers are what matter. Okay, and it says the length. Okay, so this was A down here. This was R So obviously that means we have to be solving for B. We know R is between A and B because the segment AB, that means A and B are the endpoints. Here's one endpoint, the other endpoint must be on the other side of it in order for R to be on it. So B is somewhere right up here. So you can just put that like that and put a B next to it. Okay, and that's our one that we're solving for. If you want to put the question marks, you know what we're solving for. Notice the x-coordinates stay the same. That's not changing. That's why it doesn't ask in the question, what's the x-coordinate? We already know it has to be -6. It's on this vertical line segment right here. Okay, so it's only asking for the y-coordinate. Now we look at the ratios given to us. From R to B, as I said right there, is 1 unit. So it's 1, and we're going to call it y since we're going in the y direction. 1y. From there we know is 1y, one part. And from A to R, from here to here is 3 parts. So I put a 3y right there. Okay. Now, which of these distances can we actually calculate right now? Well, obviously we can't calculate this R to B because we don't know what B is. But we do know what A and R are, so we can figure out that. How far is from A to R? -6 to -3 is a total of 3. Okay. So now I can just set that equal to 3. 3y equals 3. So therefore, y equals 1. So that means each part is 1 unit long. And don't forget, from R to B is 1 unit. So 1 times the 1 is 1. So I'm just going up 1 from point R. Well, what is point R? -6, 3. Which one is being changed? The X? No, it's not. So that stays. The Y. So what's happening to the Y? Am I going up or am I going down? Obviously, I'm going up. So I'm adding 1 to the Y coordinate. So what is -3 plus 1, which I have written down here? -2. There's my answer. Right, over here, number 10, what's the exact distance for comma -5 is from the origin. If you need to plot that, go ahead and plot that. Okay, so, and just, again, it just matters how you label it. So 4, say -5 right there. That means that this distance from the origin right here, that's what I'm trying to calculate. Okay, so I went 4 to the right, and I went 5 down. So this is 5. Okay. So now we have Pythagorean theorem, right triangle. Okay. 4 squared is 16 plus 5 squared is 25. 25 plus 16 is 41. And then we have to take the square root because that's c squared, or d squared if you want to call it distance. So you get down to d or c, you have to take the square root of both sides. So you get square root of 41. That does not break down. So we leave it right there because it wants the exact distance. That means you do not put it as a decimal or you're going to lose points. Lose a point. Okay. Number 5. Now, we've done this multiple times in the past where they don't tell me the ratio that it is from A to B. We just know that the ratio is 3 to 2 from A to B, or I could switch it and go 2 to 3 from A. Or I could say it's 3 to 2 from B, which means 3/5 from B, or I could switch it and make it 2/5 from B. Either one. Okay, so I chose to use A. So again, if you want to plot the points, and again, if you did this on an actual XY plane, and then you got your answers, you'd be able to check it to see if those answers line up right on your line segment. So -9, 8. Okay, we'll estimate, let's say, is right there, and then the other point is -4, 3. Say right there. Okay, and so we have A and B, and we know R is somewhere in between. Okay, it's either going to be 3/5 from A or 2/5. If I go 2 to 3, switch the order, either 3/5 or 2/5 from A. I'm just choosing to use A. Since I'm using A, of course, I write down the X and Y, I write down the X and Y coordinates of A, -9 and 8. Now don't forget R is somewhere in here, 3/5 of the way. Oops. Let's put a dot. So if we use this first ratio, it's 3/5 of the way. So it's just over half. Okay, so R could be there, or if I switch to R to be 2/5 away, it would be a little bit less than half. Okay, so there's my 2 spots that R could be, just estimating wise. Okay, I'm just going to put this in here, but there's two of them. It's either one of these two right here. All right, so again, now I'm going to draw myself my triangle. So I know I'm going the x direction, I'm going positive. That's why after I put down the x coordinate, it's a plus sign. And in the y direction, after I write down the y coordinate of 8, I'm going down. So the y sign is negative. And again, our first ratio, just leave it as is, 3 out of the total of 5 parts, 3/5. And remember what goes in parentheses each time is the total x distance here. What is total from -9 to -4 is total of 5. And then for the y distance, 8 to 3 is also 5. Okay, so now you just put in a calculator, or you can just cancel it out in your head. 5 cancels here, and you have -9 plus 3 is -6. The 5's cancel here, and you get 8 minus 3 is 5. If you can't do that, just put in a calculator and do it. So that's if the ratio is 3 to 5. Now if I switch and put the 2 here and the 3 here, that ratio now is 2/5. Notice I'm going from A, so the x coordinates don't change, the signs don't change, so that's why you see the signs don't change, and the x distance and the y distance doesn't change, that's why it's still 5's here. So this is the easiest way to do it. If you do it from the same point 2 times, the only thing that ends up changing are these ratios. So now it's just 2/5 instead. So again, these nicely cancel out. So -9 plus 2 is -7, and 8 minus 2 is 6. And so the first point would be -6, 5 right there, and that would be -7, 6 right there. And they'd both line up right on the line right there for you to check if you actually graph it on your XY coordinate plane. All right, number 11 now. Determine the type of triangle. So again, I plot the 3 points. Okay, draw a rectangle around them. So it connects at the vertices there. And then I'm going to find each distance, just like we did right up here. And question number 7, find the exact perimeter. We're doing that same thing here, so we check the side lengths to see if we have 2 of them the same, then it'll be isosceles. If it was none of them are the same, then it's scalene. If all 3 happen to be the same, it'll be equilateral. But notice I don't even put that up here, so it's not going to be one of the answers anyway. And then we need to check to see if this is a right angle right here. If this is a perpendicular slope, which means negative reciprocals. Okay, so here we have 7 squared. Now, here's the one nice thing. If I just write down all these numbers, I count up 7 and 2. Okay, well, 49 and 4 is 53. That's obviously not 3, 4, and this would be a 5 for Pythagorean triple. And that's 25 and 9 is 34. So each one of these gives me a different number. Okay, here I'd have the square root of 53. Here's 5, and here is square root of 34. So it's scalene, all 3 sides. Now it could be a scalene right triangle now. So I have to check to see if this is a right angle. Well, how I check that is I get the slope of both of those segments. Well, the slope from here to here, obviously I went up 3 and right 5. So that slope is 3/5. Okay, so that slope, if I go ahead and write that down, will be 3/5. And then the other slope is going from this point down to this point. I went down 4. Remember, it's changing y over changing x. So down 4, right 3, -4/3. Okay, so these are the 2 slopes I'm comparing. Are those negative reciprocals somewhere there? The answer is no. So even though it might look like a right angle, it is not. They're not negative reciprocals. Another way to test that, if you forget that, is the 2 slopes must multiply to -1. 3/5 times -4/3 is not -1. So therefore, this is not a right angle. So it's not a right scalene triangle. It's only scalene. Okay, and there's your answer for that. All right, flip it over to the next page. Next side. Volume. As I pointed out multiple times in class, you may do it the vertical method as I like to do it. It then lines up the common terms nicely like you did in multiplication in elementary school. But if you want to do it horizontally and do distributive property and then combine like terms after that, that's fine as well. You'll get the same answer if you do it correctly. So first off, I have a 3 and a 3. I'm going to put it in highest order down. So 3a and then 3. Okay, degree 1, degree 0. I don't write 2 plus 2a. I'm putting 2a plus 2, highest degree down. By doing that, that's going to help me to line up the terms correctly when I multiply this through. And then I just go 2 times 3 is 6, 2 times 3a is 6a. It's just like elementary school multiplication. 2a times 3 is 6a. Notice these are lined up now. And 2a times 3a is 6a squared. Now I'm just adding straight down. That gives me this answer right here, which then I went ahead and wrote up here. And now I multiply that by the third side. Again, I put the highest term first, 3a plus 7. 7 times 6 is 42. 7 times 12a is 84a. 7 times 6a squared, 42a squared. 3a times 6a is 18a, so it lines up underneath the a's. 3a times 12a squared is 36a squared, lines up under the a squares, and 3a times 6a squared is 18a cubed. And now I just go ahead and add straight down. The terms are already lined up correctly, and there's my answer up there. Okay, each term, since every problem's worth 4 points, each term is 1 point in this particular answer. All right, line segment AB, whose endpoints are these, is the image of CD. So CD was the pre-image after a dilation of 1/4. So it took CD, multiplied by 1/4. It got 4 times smaller to get AB right here. Now, what students missed on this is they didn't understand what, when it says what is, quote, CD. Well, they thought that meant what are the coordinates of C and D, like these coordinates. That doesn't know what it means. We've been talking about this all year long. You start to learn this in quarter one. When I have CD with nothing above it, that means the length of CD, or the distance from C to D. So that means I need to find this distance. And then to go backwards, I multiply by the reciprocal, because this was 1/4 of the original of CD. So to go backwards, I multiply the reciprocal, which is 4. So I first find this distance, so distance formula or Pythagorean theorem, same thing. So that's the square root of 12 minus 4 is 8 squared plus, not minus, and then 14 minus the minus 2 is 16 squared. So I have 64 plus 256, which adds to 320. Square root of 320 breaks down to 16 times 20, and that breaks down to a 4, and that's 2 root 5. 4 times 2 root 5 is 8 root 5. So that's what this distance is 8 root 5. And then I have to multiply by the reciprocal 4. 4, remember, can't multiply that with the radical because it's not underneath the radical. So I'm just doing the 4 times 8, and I get 32 root 5. Okay, and there's my answer. If you want to put U on it for units, that's fine as well. Okay, I didn't mark anybody off if they didn't put that there. All right, 17. The line 2y equals negative 3x plus 6 is transformed by dilation of 3, centered at the origin. What's the equation of the image? Well, the one thing you need to remember here is that the slope does not change. Well, right now, the slope is not negative 3, as some people thought. You have to first solve for y to get the slope. So you divide each term by 2, and you get y equals negative 3 times x plus 3. This is the actual equation in slope-intercept form. The slope does not change. Here's my slope. So that's going to remain the same. So y equals negative 3 halves x remains the same. What changes, since it's centered at the origin, so it's not on the line itself, it's centered at the origin, all I do is multiply the y-intercept by the dilation. So 3 times 3 is 9, and there's my answer. Okay. Number 18. What are the coordinates of P prime when I first reflect it over the line y equals x and then dilate it 7 times? So that means at the origin. So remember, this little circle here means following. So do dilation following the reflection. I'm going to do the reflection first. You remember from when you're doing transformations, all those transformation pages. When you reflect over the line y equals x, it switches the x and y coordinates. So now I have 5, negative 2. Now I apply the dilation to it. Very simple. I'll just take that 7 and multiply by both those, and you get negative or positive 35 comma negative 14. There's my answer. Nice and simple there. All right. What is the slope of the image of the line? We had a lot of people who missed this who wrote an equation, like up here. They thought it was asking, it didn't ask for what the equation is. Here, this is what's an equation. So we write an equation. Here it asks for what's the slope. You should circle the word slope or underline it. All I want is slope. We know in any dilation, the slope remains the same. It does not change, just like it didn't change up here. So the only thing we have to do here is figure out what the slope is. Oh, it's already in slope-intercept form. Y equals mx plus b. So there's my slope. 4 over negative 8. All I have to do is reduce that to negative 1/2. It's the same slope, and you're done. That should be the easiest question on the whole test. Just take that number right there, and if it simplifies, simplify it, and you're done. Okay, 20, and then we'll come back to these two over here. What's the center and exact radius of the circle? Remember, on the circle, we need all of our x's and y's to one side, and we can leave the constants to the right side. So I add the y squared across, and I subtract the 8x across. Remember, the x's stay together and the y's stay together. So now I need to complete the square. Remember, I'm completing the square. To get this right here, to complete this square right here, I have to take half of b. So half of -8 is -4. -4 squared is 16. There's nothing with the y squared, so it's just y squared. So that point will be 0. Okay, and since I added 16 to the left, I must add 16 to the right so that I don't change the equation at all. I added 16 to the left side, so I have to add 16 to the right. Now this factors perfectly into a perfect square. X minus 4 quantity squared. This x is always going to be the square root of this, and this number right here is always going to be 1/2 of b. Remember, this is b right here, the coefficient of x. So half of -8 is -4 every time. We've done this over and over. Okay, and so I have x minus 4 squared. If I want to check, I could multiply that back out, and I would get that right there. So I know I'm right. Plus y squared equals 32. And then remember, to identify the center, it's the opposite, and the square root. So the opposite of -4 is +4, opposite of 0 is still 0, and then the square root of 32. I must reduce the square root of 32, so it reduces down to 4 root 2. Square root of 16 times the square root of 2 breaks down to 4 root 2. Okay, so there's your answer for that. Now over here to 13 and 14. 13 and 14 are actually very similar because they use almost the same formula. Notice when I look at the formula, the volume of a cylinder is pi r squared h, and the volume of a cone is 1/3 pi r squared h. So the only difference is 1/3 out front, so it should be very easy to remember those two formulas. Okay, so I look at what's given here. Fill in the given information. BA is 22. Put a 22 right there. Angle BAC is 60 degrees. Put a 60 right there. BE, which is the diameter, is 8. So that means the radius is 4 right there. Okay, now I'm just filling in the formula. Pi r, which I already just calculated 4, so 4 squared. And now I need to calculate the height. This is our special right triangle. It's 30, 60, 90. So that means this up here is the 30-degree angle. We know the 30-degree angle is half of the hypotenuse. Since the hypotenuse is 22, that makes the 30-degree side, which is opposite the 30-degree angle, 11. Then we know the 60-degree angle side, which is across from the 60-degree angle, is always root 3 times longer than the 30-degree side. So I just add on the root 3 there. So now this is the height. Remember, the height must be at a perpendicular to the base. So the height can be outside of the figure as it is here. Okay, so there's my height, 11 root 3. So I just fill it in for the height. And 4 squared is 16 times 11. Wait a sec here. Why do I have 16? Why do I have 480? That should not be. 16 times 11 is 176. Equals 176. 4 pi r squared. So we got r squared 16 times the height right there. So 16 times 11, 160 plus 16 is 176. This actually should be saying 176. There's an error there. Good thing I'm going over this. 176 pi right here in root 3. Okay, exact. That's the key here. I'm doing exact. That means I do not put pi in the calculator. So we had a bunch of people putting in the decimal answer and root 3 in your calculator. You don't do that. You gotta leave the radical and the pi in there. So the answer should be 176 pi square root of 3 cubic units. Volume, remember, is always cubic units. Okay, so just know that that's 176, not 480. I wonder if I did 864 times 11. Now I don't even know what I did to get that 480. I don't know on that, where that came from. I don't want to waste the time trying to think about it right now, but 176 pi. Okay, 16 times 11 is 176. All right, so similar idea here. This one I did, I plugged in the numbers right here. I just didn't do the calculation right. So I plugged in the numbers right here as well. CF, they tell me, is 6. That's the radius. So that's why it's plugged in as a radius. Remember, this is just 1/3 pi r squared h. There's 1/3. And now I again need to find the h. The AC was 24. The ACB was 60. So it's just like this up here. This will be my 30 right there, which makes this side half the hypotenuse, 12. And this 60-degree side is always root 3 times longer, 12 root 3. So now this one, it says nearest hundredth. So this one, you plug all of this in your calculator, type all that in your calculator, and you should get that answer right there. And since this is volume, again, it's cubic units. All right, last one, 15. 15, we have is a right triangular prism. Volume is always the easiest to calculate. It's the area of the base. Capital B stands for area of the base. The base is the one that is being stacked. You can see that this triangle is being stacked BE in height or CD in height, which happens to be 7. So that's where the 7 is for the height. And then we need to find the area of the base. Well, they gave us CD, 7, okay. They gave me AC is 24 and AB is 7. And that's my right angle. Okay, so I have a 7, 24, 25 Pythagorean triple. Okay, to get this length of 25. And I don't need that for the volume part. I'll use that with the surface area part coming up. Volume is area of the base. So the area of the base is this base figure is a triangle. What's the area of a triangle? 1/2 base times the height. So half of 24 is 12 times 7 is 84. So that's the area of the base times the height, 7. 84 times 7, 588. Okay, and it's volume, so it's cubic units. 2 points that one, and then 2 points for this one. Surface area means calculate the area of each face. Face, remember, is the side, the area of each side. They're called faces, vocab wise. Okay, so we just calculate this area. 12 times 7 is 84, and of course we have the top and the bottom, so that's the 84 times 2. This length of this rectangle here is 25 times 7. Okay. And then we have 7 times 7 for this rectangle over here. And we have 24 times 7. So I could have added up each of those individually. Or what I did here is another formula to help for any rectangular prism is add up the perimeter of the base, which is the 24 plus 25 plus 9, that's the 56 right here, times the height. So that's little p for perimeter of the base times the height. That's what I did right there. So if you want to remember that, you can. Otherwise, just go ahead and calculate the area of each side and add them all together. That's what surface area means. And you'll still get 560. Okay? And that concludes the explanation of every problem on here. So anybody need a retest, you should watch this video, make a note. Now remember, for those retesting, maxing out at a 75, you need to get 12.5 right. Remember, this is great on a rubric scale. So you don't have to know how to do all 20 because you're only going to get 75% back. So you want to say, make sure you not do 14 in case you make a mistake on 1 and 1.5 of them. So you still get your 12.5 back for a total of 75. Okay, so if any of these still remain hard to you, you can take out basically 6 of them and just focus on the 14 that you really know and are easier for you to understand and or memorize. Okay, to get 14 correct, and then you're guaranteed to get your 75% back. And you'll do that if you don't have lab class, you'll do it during class on Thursday or Friday while other people are working on the assignment. And of course, I've sent home the video of the assignment that you should be taking notes on yourself already, so that you have those notes and you've watched and learned ahead of time. So then you can just focus on doing this retest, and then when you're done, you go ahead and work on the assignment yourself because you've already taken your notes on it. And then if you have any individual questions from after listening to the video and you still don't understand, you can ask me those questions after you're done with the test while everybody else is working on the assignment. All right, so I will see you Thursday or Friday, whichever day you have a class. That ends this session.